Hello and welcome to the story of Atlatl, from Inception to 2020.
Hi, I'm Dan from Idle Hands, and I'm here to talk to you about Atlatl, the first retracting tethered projectile combat robot, at least as far as I know. I'm going to be going over everything that got it to where it is today, as well as what it needs to have done to it in the future to make it more competitive. I'll have timestamps in the description for each major milestone. I'll be going over the pre-Atlatl designs that eventually led to the 30-pound sportsman you see in front of you today. I will then go over its version 1 sportsman build and its subsequent competition in Motorama 2019, and then go over its version 2 rebuild for Motorama 2020. When I first started doing combat robotics, I had very little experience. I had done first robotics in high school in 2003, and I tinkered with cars a bit, but otherwise I was a software developer with very little experience in this area. When I first started getting back into this in 2016, I looked around my local area to see what I could find for competition. Within my province there was only sumo, which wasn't really interesting to me at the time, and I'd have to travel thousands of kilometers to get into combat robotics, and that would only go up to 3 pounds. So with that as it was, I figured, why not go big? After all, Battlebots and Robot Wars are back on TV, and robo games exist, so why not go big and just build a heavyweight? I called up my friend Amanda and said, hey, would you like to do this with me? She was on board, so we decided to give it a roll. And with that, I'll lead into the pre-ideas that led to Atlatl's design, that is, the heavyweight initial ideas, back when we had no idea what we were doing.
So the first idea was, why not try a rapid linear actuating force? Basically, jab at him with a spear. If everyone's coming at you with rotating weapons, maybe there's some kind of edge that can be gained with linear weapons. So the first idea was, let's just power it with a pneumatic tank and run it at full pressure, 1000 psi, see what happens. But after seeing some footage of it on Robot Wars, and it mainly just pushing people, the idea was quickly scrapped. The next idea was to look into springs. Since spring compressors in the car world are frequently commented on for being extremely dangerous, it must work for intentionally causing harm. So we mocked up some ideas and decided to check out some real-world tests. The idea here was to use an impact wrench to see how well a spring could be reeled in under tension, as well as what kind of force it would actually take to do so. The idea of screws failed, as the threads ended up binding to the nuts. As a note, when actually winding up the springs, the box was closed for safety. So the follow-up idea was to eliminate using screws to compress the spring. Also at this point I tried reaching out to some mechanical engineers, but they were mostly too busy to help. Upon reflection, this idea looked too prone to issues. Compressing the spring with a winch required one heavy-duty winch, so investigation into hydraulics was done next. A continuous concern with these ideas has been how to release the weapon reasonably under tension. So taking some inspiration from a crossbow, an idea for this, as well as an idea for a winch that doesn't need to provide the force for compressing the springs, was done. This idea even had some hydraulics and wiring planned out and some theoretical components picked. It still felt a bit tricky, so next electromagnetism was investigated. Using the program FEM, along with some Lewis scripting, we ran several simulations involving heavily shielded windings and many different stages to see what we could get. Crunched the numbers, and in the end, when considering the weight for copper, capacitors, and shielding, it was not more weight efficient than using springs with the 220-volt rule at the time. At 400 volts, this may have been reasonable. All of this doesn't matter anymore, as I'm guessing someone else asked about this, as the new rule no longer allows us for crazy high voltages. At around this time, I'd met up with the local robot group, which is now doing full combat at the 1 and 3 pound level, and also learned about Motorama. After discussing some ideas with people in the robotics club, and hearing that springs are hard from experienced builders, along with seeing some footage of flywheel, axe, and flipper bots, the plan forward was to go with a 30-pound sportsman powered by a flywheel, and named for Motorama 2019. With still growing CAD knowledge, a lack of some essential tools like a drill press, a 3D printer, or even a 2D printer, it was time to start. A test chassis was cut out of MDF and the drive system was put together. The rear wheels were directly driven off of the gearboxes, and the front wheels were chain-driven. Brushless drive was going to be used, and that meant programming the speed controllers. After a couple attempts to build the flash tool, the code needed to be set up. Unfortunately, the Java-based compile and flashing program the online tutorials used had issues and referenced dead pages, so the code needed to be collected and compiled manually. Fortunately, since I'm a programmer, this wasn't too bad of a task. Some tweaking of the include files and the necessary code changes, and it was good to go. Break was left off at the time for reasons I can't exactly remember, though in hindsight it shouldn't have been. Some parts of the robot needed to be 3D printed. Fortunately, the library provided access to some printers for a fee. Only a few parts were 3D printed for Atlatl, but my inexperience, oversights, and occasional imperfections caused for several iterations of some parts, but in the end it all worked out fine. The main pieces connecting the chassis were 1/8-inch C-brackets made of steel. I couldn't find C-brackets in the size I wanted, so I made them. Fortunately, I received a chop saw around this time, and did have one fancy tool, a welder. So after hand drilling the holes, I was able to weld them together. The nuts were welded on last, as they only came a few days before the event. The winch mechanism didn't have an advanced detailed plan, just an idea. That turned out to be a bad way of doing things. But anyway, The plan was to have a fixed motor, an idler pulley, and a pulley attached to the winch shaft. The idler pulley would only add tension when needed to retract the spear, so firing the weapon wouldn't throw any real forces into the motor. The winch shaft was simple. A D-shaft was made on the end with an angle grinder, and a pulley was added. The idler pulley servo had a mount made along with a bracket for the idler pulley. This didn't work out well, so the idler pulley was scrapped and the motor was moved onto the servo. As you can see, it didn't work great. Final revision was made to reduce the belt escaping. A simple speed controller was made for the motor and was actuated with a toggle switch. A flywheel was used to transfer energy into the spear to throw it. The flywheel would be held in place by two brackets. The top bracket ended up being moved to the front wall, as the sides were UHNW and it was easier to fit everything in that way. The flywheel is around 3 pounds and had 2 holes tapped into it for attaching the rubber along with some glue. Shout out to Allen Industrial Rubber for giving me some rubber to experiment with. The motor drove the flywheel by having its can press against the rubber on the flywheel. The shaft was cut down with an angle grinder in order for it to fit. The weapon itself was inside a UHMW sheath that was held together with duct tape. The spear was cold rolled steel cut into a point on both ends, again with an angle grinder, and a hole was drilled in for the tether. The tether was just some nylon rope. Wire was considered, but it didn't bend enough at the strength we wanted, so it was avoided. The firing mechanism was just a servo attached to a bracket with a shaft that moved the weapon sheath back and forth. The wiring was a bit more complicated than average, but not too crazy. 12-volt power went through a finger tech switch to feed the auxiliary system and activate a relay, which in turn powered the drive and weapon systems with 24 volts. So now for the final recap. This is the robot the night before the competition, with some of the wiring still being done. The drive is accomplished with brushless motors powering the rear wheels with chains to drive the front wheels. The weapon motor powers the flywheel through direct contact, which can then make contact with the spear, which is stored in its safety box here. The launching happens when the spear's sheath is actuated towards the flywheel by the servo here. The winch mechanism reels the spear back in using this servo and motor controlled by the microcontroller here. The speed controllers and the main battery are located here, and the auxiliary battery is located here. So we left for Motorama at around 8 p.m. the night before and got to the hotel at 2 a.m. and still had some work to do. After finishing the wiring, sleeping for 2 hours, and drilling a last-minute hole to access the power switch, it was done, 10 minutes before weigh-in. We passed safety, except the weapon didn't fire, so we opened it up.
Alright, so we just went through our safety inspection. Everything passed except firing the weapon. It looks like what happened is our weapon did engage with the spear, but tore the rubber out of the weapon, which means that that extra bump, this motor can't get over anymore, and we couldn't spin anymore, and we just didn't engage well enough, or at least adhere, is that the right? I don't know, this well enough to that.
The other thing that could have happened is it could have ripped it immediately the second we made contact, maybe it ripped it off, and that very next one, the motor couldn't spin anymore, so it didn't fire because it only went that far.
Ah, yeah, maybe.
We fiddled around with it and added some electrical tape to the motor can and flywheel to have the two pressed together more firmly. It seemed to be able to spin at this point. Our first match was against a former champion, Pitter Patter. The footage here is courtesy of the Northeast Robotics Club. A link will be in the description if you want to watch the raw fight. We talked to the builder a bit before the match, and he said he'd let us try to take a shot against him.
Fight, robots, fight!
The match began, we got lined up, the weapon was spinning, and nothing. Clearly we've not got the system working yet.
Oh, Pitter Patter able to push his opponent around.
There was a second attempt to fire, but that also didn't work out.
That saw blade spin up to speed. It's going to want to put it into a corner and come down just like that, trying to find the weaker points. These robots tend to be a little weakly armored on their top plates. Oh goodness, seems to have cut in there. Now we're only going to allow them...
We attempt to move out of the corner when Pitter Patter backs off for a moment, but can't.
Uh-oh, we seem to have some functionality problems there. Pitter Patter cutting into place.
At that point we tap out and go check on the bot.
Oh, we have a tap out. Ladies and gentlemen, your winner by tap out, Pitter Patter.
Atlatl's armor is a 1/4 inch thick aluminum, and the saw blade went through about 80% at its worst. The flywheel looked like it definitely rubbed against the weapon, the energy just didn't transfer well enough. Our next match was against True Grit. After we'd gone for lunch, we checked the drive, and it seemed fine. This led us to believe that the speed controllers had just overheated, as the drive chains had popped off binding the system, and that's what went wrong. Turns out no. When doing final checks before heading to the box, we'd noticed that the pinion gear is what had failed. We attempted to fix it in time, but to no avail, and did not compete in the next fight. Important lesson: always test your bod in the test box after you think it's ready. So that was the end of Motorama 2019. People there were very nice and helpful. Several people we met would prove to be very useful in the following year with their inputs on Atlatl version 2. With Motorama over, it was time to invest in some infrastructure. A couple of weeks before the event, I was given an old drill press, which I was very grateful for. I picked up a 3D printer and built an enclosure for it. I then purchased, printed, and built a CNC machine using an MP CNC kit. I couldn't get it square. The rails were just cheap conduit from the hardware store, and I suspected that's why. To handle this, I wrote a program to adjust any G-code I generate to compensate. During the following year, I'm also competing in local events, and out of desire for more flexibility and cost savings, built my own controller. The weapon system needed to be changed to apply more pressure to it, so the firing mechanism was redesigned to use a screw, which can't be back-driven. Alright, so this is the prototype weaponry for Atlatl for Motorama. So basically the way it's going to work here is we're going to have a motor spin up a flywheel. This is just for the prototype version. Whether or not we have a direct drive on the rubber or not is to be determined. So basically this will spin up this flywheel here, and what will happen is we will power this motor here, which will engage these gears to cause this whole contraption here to pull forward. The idea is that it will squeeze these roller bearings here into the rubber of the flywheel here, and it will start to push it forward. As it pushes forward, this is tapered outward, and it will cause it to squeeze harder and harder, give it much more bite onto it. The final result will be using much harder rubber than this, and then yeah, it should just sail through and fire. The firing mechanism striker would twist as the spear pushed past, so some guides were designed on the tops and bottoms of it to help it stay in place. The flywheel also jiggles, but that was already planned to be supported from the top and bottom. The flywheel, being driven by the can of the motor, has a few problems. Keeping tension between the motor and the flywheel can be problematic, though this can be solved by a spring. As the rubber wears in chunks, it would cause impacts on the spinning motor from the new indentations in the rubber, so the system was changed to be belt-driven. Talks with Magneto's builder aimed my design to one where the rubber could be easily replaced. After all, it's a consumable and will need to be swapped out at times. This led to a design of a paddle-like shaft. The idea was to use a hockey puck as the consumable. After all, they're really cheap and really easy to get a hold of, and can handle high speeds. The paddle-like shaft would apply a wide surface area of force on the puck, which should stop it from distorting and spinning in place during weapon engagement. 2 disc styles were designed to be used as the mass and could easily be laser cut. I could machine the pucks myself, and the shaft wouldn't be too complex for a machinist to make. Machining the pucks actually went quite smoothly. I machined an insert for them, milled half the puck, flipped it, and then added a block to keep the reference for machining the other side. It being between -10 and -20 at the time likely made the machining of rubber go more smoothly. The laser cut discs were a little oversized as I didn't want to try and file them down at the time, and I ended up using aluminum tape as shims to hold them in place. I balanced the flywheel by 3D printing a holder with some bearings and cutting away at the heavy sides with an angle grinder. The bearings were held in place on Atlatl by some blocks I machined myself. The winch mechanism had less space than last year to work with. The desire was to use only a single motor. The magnetic clutch looked like it could work in theory, but given the space constraints and sizes I was working with, I didn't know if I could make it work. I stumbled across a video of how a pullback car works and saw its mechanics were similar to what I want. I designed a system that used 3 gears, one on the winch shaft, one on the motor, and a third gear that can engage and disengage the system using forces provided by the drive motor. Alright, so this is the winch prototype for Atlatl. So basically the idea is we have a motor here that drives just a gear that's in here. It's hard to see, it's in there. When this motor spins, clockwise, what will happen is it will push this gear forward into here, engaging the winch, spin, and reel this in. And then when we get the motor to spin counterclockwise, the force of it will actually pull this out of the way and allow it so that when the motor fires, the entire winching system is completely disengaged from it. And then we'll see here, winching in, works, and then we winch away, gets out of the way. Like that. Single motor winch mechanism with a clutch. This worked very well as a prototype and didn't need much further iteration to get it in Atlatl. The bulky nylon winch rope was traded out for some thinner, stronger UHMW PE rope rated for 460 pounds. The spear was changed from solid steel to solid aluminum with a steel head. The aluminum shaft was milled on my CNC machine and the spearhead was cut with an angle grinder. This was done for two reasons. One, throwing less mass should be easier, and two, the design prevents the spear from retracting too far. The drive had very little change, the only addition was some chain tensioners. The C-bracket chassis supports were dropped in place of solid aluminum pillars with holes tapped wherever needed, basically specialized nut strips. To prevent needing to undo a ton of screws to take the top plate off, but still support the robot more, a bunch of plastic tabs, pictured in black, were screwed into the inside of the top plate so it could just be slid on. The clearance on these tabs was too tight, and I didn't have enough time to reprint them, so most were just left off. The wiring was a bit more complicated this time due to using a microcontroller receiver instead of plain RC receivers. Trading out the servos for a regular DC motor required some additional speed controller wiring, plus there was a limit switch added to track the position of the firing mechanism striker. The power relay was dropped in favor of a second, higher current switch, so overall, not too bad, though I will say, soldering in -20 sucks. Some of the gears were 3D printed in nylon for their final form. I waited until the end to do this in case I messed up my printer and had to stick with the PLA placeholders. I did damage the temperature sensor in the printer a bit, but it held up until several months after Motorama. The robot was mostly buttoned up and ready for testing a whole 5 days before the event. Let's see what the first spin-up test looked like.
Alright, so my guess at what happened is flywheel spun up and it hit some high speed. Don't know what. But the puck actually deformed and stretched and bumped into here, like the support pillar, and just, rubbed right against this, making a good amount of smoke and smearing a good amount of schmoo over here. So that means that this will not be able to operate at top speed. But it'll operate at us speed.
So that wasn't great. At this point there were some ideas to reduce this problem, like wrapping a thin wire around the puck, or drilling some holes through the puck and flywheel and adding some dowels to reduce the stretch. These ideas were abandoned in the interest of more testing time and having something working as opposed to risking wasting time on ideas that might not work. This means that the flywheel will only be spinning at about 10% power to stop the puck from crashing into the chassis. Firing and retracting had some hitches, but some tuning in the striker and retract functionality through the Arduino helped alleviate that. With Atlatl all ready to go, we left Thursday afternoon to go to Motorama. We were competing with a ferry on Friday, which I won't get into in this video, but it did cut off a day of testing and fiddling with Atlatl. On Saturday, our robot passed safety, but revealed a problem with it. Basically, the rope was snapping on any shot where we missed the target. This was due to tight angles from the knots in the rope causing weak points. A few iterations of knot tying by Amanda and test firing, and we got something that should hold for the first fight. This was good, as we were the first sportsman fight. We had a friendly conversation with our opponent, Humphrey Hugabear's builder, and then it was time to fight. Basically, for Motorama to be a success, in a fight I wanted to fire the weapon, reel it in, and then fire it again. It'd be a complete proof the weapon worked, even if it was to minimal effectiveness. The match started off about as well as I expected. Having only driven the robot for a couple minutes, my control was not the greatest. The controller wasn't tuned to limit the speed of the flywheel, so I just had to guess at this point and hope I didn't go too fast or too slow. Hearing how fast the flywheel is spinning is difficult, as the box insulates sound well and Motorama is loud. You can see when being bumped around that the spear pops out a little bit. I can't remember if that was from being tossed around or if that was just a slight misfire. At this point he seems to be getting less aggressive towards me. I'm not sure if he's giving me a chance to shoot or sorting out an issue with his bot, but you can see a belt come loose. I do manage to get a shot off after a bit, The firing mechanism striker does not move the fastest into the spear, so it does have a noticeable delay of around a second or so. The spear then goes under Humphrey, and we struggle to pull apart. At this point, neither of us want to be in this situation, and if the tether tangles into his wheels, the organizers may cut it off to resolve the entanglement. A few close calls with the rope almost wrapping around his wheel, and eventually I'm free and he's flipped over.
Alt, oh, he's dragging it back in! Reloading the cannon! Yes!
Fantastic, got it reeled back in. Just have to make one more shot and my goal is complete.
Lining him up, lining him up.
So that shot is a total whiff, but at least it's an easy retract and try again.
Alt, he's loaded again. He's ready for shot number 3. Humphrey Hugabear.
And another bad shot. I'm aware I'm not going to do any damage with this, but it's nice if it at least hits him.
May have been disabled by the rocket catapult of Alt. Oh, there. Oh.
Another either misfire or slip up. I'm not sure how fast the flywheel is going at this point. When running it at this low power, it actually takes quite a while to spin up. Another shot. I'm not sure if that skids off his armor or is a complete miss. So far, even with all the half problems in the bot, it's working pretty great in my mind. My only strategy right now is to try and fire the weapon at him as many times as possible, foregoing anything like aggression. In an attempt to get more speed into the spear, I tried pushing the flywheel speed up some more. That results in the puck crashing into the inside of the bot and smoking, so I have to spin down again. At this point I'm yelling that it's rubber smoke, in case they think it's a fire and eliminate me, but I've lost my voice and nobody can hear me. Fortunately though, they didn't think it was a fire. The spear is no longer retracting at this point, and it's due to a hitch I'd mentioned slightly in the build process. Near the very end of the build, I had to redesign the high voltage wiring box in order to make it all fit. The box didn't provide enough clearance for the winch mechanism, and it can jam if it moves too aggressively or I'm bumped at the wrong time. And that's basically what happened. I know it can be banged back into place if the robot is hit hard enough from behind, so I back into the wall a few times.
Humphrey Hugabear trying to make it over to Alt trying to figure out why his harpoon is not retracting.
At this point the drive starts acting up a bit.
Both robots seem to have some sort of driving difficulties, each doing their own thing respectively in the corner. 10 seconds left, drivers, 10 seconds. 5, 4, 3, 2, 1. That's it.
And that's the match. So this results in a split judge's decision, which is incredible as it's the second best result I've ever had, but it still results in a loss. I'm sure the smoking puck, which happened at the same time the winch jammed, didn't look good. I imagine if I spent the last minute just trying to ram Humphrey Hugabear, I would have won, but that wasn't my goal. You can see the effect of the puck crashing into Atlatl's chassis as it left rubber all over the place just like it did in testing, but it wasn't much to clean up. Both of the chains had popped off. I believe the impacts from backing into the walls, paired with the absence of drive supports on the lid and some looseness in the chain, caused enough flex for them to fall off. To remedy this, for the next fight, we added more chain tensioners and borrowed some half-links from Team Botshed to get it really tight. A piece of tape was added to the retracting mechanism to stop the clutch gear from going too far forward and getting stuck again. The tether had worn from all of the action in the fight and was replaced with some fresh rope. The spear had good amounts of rubber burned onto it, which we wiped down for the next match. Our next match is against Ralph. He said he was fine with us taking the first shot on him for fun. I don't know if he knew how harmless our weapon was, or if he just wanted to see what would happen. Either way, that's great for us. So this first shot is about as picturesque as one could hope for.
Fire cannon 1. Yes! It did it! It did it! Reel it back in. That is so cool. That is so stinking cool. Fire cannon 2.
You can hear the flywheel spinning up pretty well, but that second shot didn't go so well. I suspect more spin-up time was needed. The third shot comes out nice in that Atlatl is moving and shooting at the same time and hits the target. Then Ralph reveals 2 problems in quick succession. The easily visible problem is that Atlatl can be high-centered on its own weapon. I'm not sure if the retraction system could pull it out from under itself, but based on the angle of a perfect shot like that, I'm doubtful. The second was user error. Atlatl is programmed to run in 2 modes, normal mode and combat mode. In normal mode, Atlatl waits for no throttle on the flywheel before continuing, where in combat mode it skips this check. I had left Atlatl in normal mode and forgot entirely about this safety system at the moment and didn't think to switch it. The batch of Arduinos I'd got at this time seemed to reset pretty easily under impact, and that's what happened. Rolf tries to wake up Atlatl, but it's asleep that goes to the buzzer. The chains popped off again, so they were removed for the rumble happening the next day. Fortunately, the rumble revealed another issue with Atlatl. Unfortunately, it happened right at the beginning. If the flywheel isn't going when the firing mechanism striker hits the spear because, say, I didn't give it enough throttle, then the striker jams against the spear and the side rails, and its motor can't pull it back. Trying to spin up the flywheel at this point just results in the motor cogging and the spear poking in and out a little bit. There's nothing else too notable for Atlatl in this video, so I'm going to cut it short, but it is available on the Robot Conflict YouTube channel. So in the end, this was another fun event. There was some good food, and Atlatl won Coolest Robot. So this is actually outstanding. It easily made all of the suffering to get it working in time worth it. Well, nothing much left to do but to pack up and head on home. So now to go over the main enhancements to have done with Atlatl. Atlatl is currently 2.5 to 3 pounds underweight, so fortunately I have weight to play with for anything that I need to upgrade. But let's open it up and dive right in. So the chains, which are currently not on the robot right now, are fine except that they keep popping off. So new chain tensioners, probably made out of spring steel or something with like an HDPE guide, would probably work best. The drive ESCs, located under here, currently need to be tuned a bit. They have no braking and there's other fine tuning that could be done with them. The controller could be further improved. These sticks are not very accurate for getting where your position are. They're almost in a sense too sensitive. The throw on them is very low. Fortunately, since this video took so long to make, I've already done this part, but this is a story for another time. I need to actually practice driving the robot. As it stands, I typically end up spending more time in the box than I do practice driving, which is not great in the slightest, and I think actually handling the robot with some free time will help. The firing mechanism needs to move faster. Currently, the gears in here are shared with the gears that are in here, and they can just be swapped out for a better ratio. Since as it stands right now, it takes about 1 second to fire the actual weapon, reducing that down to like a third the time will seriously help, being able to hit the opponent. I'm also going to consider upgrading the motors for the firing mechanism and the winch, just to see if I can find something that's a little more appropriate. I'm planning on enhancing the flywheel to be basically a hybrid of the two designs. So the idea will be that a shaft will go through here, but like a hex or square shaft instead of this like paddle shaft. And then I'll still have discs on here, but the puck, instead of being like an entire hockey puck, will be a steel disc with rubber glued around it. That should reduce its stretching under speed. At least I think it will. The actual spear and tether will need to get some enhancements as well. The weapon shaft itself, I'll experiment with different weights if I have time, because to see if less mass will just get that much more speed out of it, because it's just that much less to accelerate. And the tether, it'll need to be enhanced to handle these higher speeds and forces it's going to be receiving. So I was thinking either something like a bungee tension on there, which is an idea I got from talking to Neptune's builder, and also having a metal cable that goes onto the end that attaches to this, so they don't have these knot pinches that are currently in there. Because whenever this rope breaks, it always breaks at a knot. So if I could make it so that this connects with a straight line to like a steel reinforced section, then hopefully that will reduce the breaking force in the rope. One final thing I'd like to mention is other projectile combat robots I've come across. There's the heavyweight projectile Battlebot Double Jeopardy, which I learned about during the creation of Atlatl version 1. There's the super heavyweight tethered projectile Battlebot Neptune, which I learned about during the creation of Atlatl version 2 and communicated with post Motorama 2020. And there's the hobbyweight sportsman projectile robot Top Hatinator, which just competed recently at Norwalk. If anyone knows of any other projectile combat robots, please let me know in the comments, and otherwise, have a great day!